All right, so welcome. I was just about to get started. So I'm going through the addition and subtraction properties of equalities or equality. These are one of the basic rules that we have that allow us to solve. There are two basic properties, the addition / subtraction, and then multiplication and division. So this is one of the basics. So we're solving linear equations, and a linear equation is specifically a type of equation where there's no, oh, I have words backwards. There are no exponents on the variables. I guess my brain was a little backwards when I was writing this. So you're not going to see any exponents on those variables. That's what makes it a linear equation. And these are also called first degree equations. Because if you had to give it an exponent, we would just give it an exponent of 1 because there's one variable basically. And we can write these equations, usually you'll see it in the form ax plus b equals c. So a, b, and c are numbers. And then you'll have your variable x. So x is the most common variable that we use. So 2x minus 5 equals 10 is that form of ax plus b equals c. But you can also see other forms that will simplify down to the basic form of ax plus b plus equals c. So the goal is you're going to have one variable. I should specify that. A linear equation. We're looking at linear equations in one variable, and you have no exponents on that variable. So if you see that, then you know you have a linear equation, and that's when you know, okay, these are the techniques that I'm going to solve. So when we're solving, when we say to solve, that means we're trying to find out what is the number that we can replace that variable with. We want to know what makes this equation true. What number can I put in for that spot? So that variable is representing the unknown number, and we're trying to figure out what that is. So that's what we mean when we say solving. And so the answer that you find at the result when you're done solving is called the solution to the equation, and we write it as a solution set. And our solution sets are inside these braces. Braces are the curly brackets. And in Connect Math, they usually already have the braces there for you. You don't have to type them in. You just type in the number. Some equations have no numbers that make the equation true. And when that happens, we say there are no solutions. And some equations have more than one number that makes it true. And if any number makes it true, if you can plug in anything into it, then we say that there are infinite solutions. Or we'll say that the solution is all real numbers, and we'll use the abbreviation R to represent that as kind of a shorthand. So we're focusing today on solving using the addition and subtraction properties of equalities. They're basically the same rule, just one's addition, one's subtraction. And adding or subtracting is adding a negative. So that's why they're basically the same rule, because if you're subtracting, you are adding a negative, and so you're just using the addition property. So they're two sides of the same coin. So in math speak, we have if a equals b, then for the addition property, it's a plus c equals b plus c. And so what this is telling us is that if we have an equation, I can add something to both sides of the equation and it's still true. If you think about it as being balanced out, if you want it to stay balanced, you have to do it on both sides. So if you have something balanced and you're adding weights, whatever you add on the left, you have to also add on the right for it to keep its balance. The subtraction property has the same idea, where you can subtract the same thing from both sides. So you could remove things from both sides of the equation to keep it balanced. So we use these properties to solve. And our goal is to get the variable by itself, because that's what we're trying to get the answer for. So these are all in the form x plus b equals c, where x is our variable. So it's basically in the form we have a variable with a number added on, or a number plus a variable, and that it's equal to another number. And our goal here is we want to get x equal to some number. Or if you have other letters, you're trying to get those other letters equal to some number. Your goal is to get the variable by itself. And we're only going to be adding or subtracting things from both sides in order to do so. So let's look at the top left here. We have x plus 6 equals 5. So I want to get this x by itself. So I need to remove that plus 6. I don't want it on the same side because I want just the x over there. So we want to get rid of the 6. And so if you have a 6 that's added on, then to get rid of it, you subtract it off. So we're going to be subtracting that 6. And if we're going to remove it from the left side, we also have to subtract 6 from the right side in order for it to stay equal. So what we do is we want to write this kind of vertically. I write down minus 6 underneath the plus 6, because that's what I'm trying to remove. And then I also write minus 6 underneath the number on the other side. So that way I can do my math vertically. So when we're solving equations, we always work vertically. We're always going from top to bottom. So don't try to go sideways or anything like that. It's top to bottom. So on the left, I have my x. And when you have 6 minus 6, that becomes 0. So it's not there anymore. You don't need to write it. So I just have my x on the left side. And then I just do my math, 5 minus 6, and that gets you -1. And so that's your answer, because now we have our variable x by itself. So we have x is equal to -1. So our solution set is -1. That is the number that when you plug it into that equation will make the equation true. And you can always check your work by replacing x with that number and then doing the order of operations and seeing if you get the same thing on both sides. Are there questions on this first example? Okay. Well, let's move to the top right. We have w plus 3 equals -5. So your goal, again, we want the variable, the letter by itself. So I want the w by itself. So I need to get rid of the plus 3. So if I've added 3, then I want to subtract it to get rid of it. So I'm going to subtract 3 from both sides. And so I end up with w on the left, and then the 3 minus 3 disappears. It goes to 0. And then we have a -5 minus 3. So -5 minus 3 comes out to a -8. Because you've got a negative, and then when you're subtracting, you're going more to the left. So we get w is equal to -8. And this means that our solution set here is -8. Bottom left, now I've got my number first instead of the variable. That is okay. So one of our properties about math, we have the commutative property, which says that the order of addition doesn't matter. So whether it's 2 plus m or m plus 2, that doesn't matter. The order that it's written there doesn't matter. So it's completely fine to have the number first and then the variable. So we're still trying, we're still trying to get the variable by itself. So I'm trying to get m by itself. And I have a +2 that's on there because it just says 2. So if there's no sign in front of it, we assume it's a +2. So we have a 2 that's on our the same side as the m that we need to get rid of. So we're going to subtract 2 away. So if you see a positive number there, you're going to subtract to get rid of it. So we're going to subtract 2, and I need to do this for both sides. So this gives me m, because 2 minus 2 is 0, so that disappears. And then we have a negative 15 minus 2, which is negative 17. And so our solution set is negative 17. That is the number that will make the equation true. Are there questions? Okay, next one here. So we've got a negative 9 equals negative 21 plus b. So I've got this b, now it's on the right side. That is okay. You don't always have to have your variable on the left. It's completely fine to have your variable on the right. So we want to get that b by itself. And added to the b is this negative 21. So you see you have a negative 21 plus b. So following our rules that we have here, we've got this negative that's added on. And so we've been subtracting to get rid of it. So you're subtracting basically a negative 21 because we have a negative 21 added to what we have. And so we need to remove it. So we need to subtract it away. So we're subtracting a negative 21. It gets a kind of unwieldy there because you're like, well, we're subtracting a negative. What does this mean? Well, subtracting a negative. So subtraction or negatives are kind of the same thing. They kind of cancel each other out. When you have two negatives written in a row like this, they cancel out to become a positive. So what we're really doing is adding 21 to both sides. Because subtracting a negative is the same as adding. So what we're really doing is adding 21 to the negative 9. So a better way to write this is we will write plus 21, and we won't deal with that subtracting negative kind of deal. It's the same thing. We're subtracting for all three of these examples. We're subtracting again, but because we're subtracting a negative, it becomes adding. So now we're actually adding 21 to both sides. So a negative 9 plus 21, and that's anything with those negatives and positives in 9, I always mess up there. So I'm doing that on my calculator, and that gives us 12. So we get 12 equals B because a negative 21 plus 21 gets you to 0. So our solution set here is 12. So for the first three problems, we had a positive that was added on to our variable, so we subtracted to get rid of it. For the fourth one, we had a negative that was added to our variable. And so when you're subtracting a negative, you ended up adding. The pattern that I want you to notice here is that whatever your number is that you're trying to get rid of, whatever that sign is, you do the opposite. So we had a plus in front of our 6, so we subtracted to get rid of it. We had a plus in front of the 3, we subtracted to get rid of it. The 2, there wasn't a plus, but it's assumed to be positive, so you subtract to get rid of it. And so for the last one here, we had a negative, so I highlighted too much. We had a minus, so we do the opposite. We add it. So the key when you're solving here is that when you want to move things, if you want to get rid of something, you do the opposite of what it is. So if you see a plus, you subtract. If you see a minus, you're going to add. And that will undo whatever was done and will end up canceling things out. Are there questions? Okay. So these are all now in the form where we've got subtraction. So all of those were something plus something. Here we have something minus something. So now these are subtraction type problems. But if we take the pattern that we just did, we basically are doing the opposite of the sign, then for subtraction problems, you're going to add. It's basically what we did in this bottom left corner. We're just now, we're just doing it and formalizing it, looking like subtraction here. And the reason why this works is because subtraction is adding a negative. So this x minus b equals c here, this form that we have, this is the same as saying we have x plus negative b equals c. So it really is that addition problem where we ended up subtracting a negative, but subtracting negative becomes adding. So that's why that last problem is basically one of these. So if you see a minus, a subtraction, you're just adding. Just remember, do the opposite of what you see. And then that will keep you on track. You'll be able to solve these. So top left, we've got x minus 2 equals 10. And we want to get that x by itself. So it's a minus 2. So to get rid of that minus 2, we need to add 2. So we have x. And then when you read this, you read that minus 2 is a negative. So you read that as a negative 2 plus 2, which cancels out and gets you 0. And then that equals 12 on the right because we have 10 plus 2. So our solution set is 12. So you want to remember that your minus and the plus, a minus sign and a plus sign is the same as a negative and a plus sign, and subtraction is read as a negative as well. That's why we use the same symbol, because they basically mean the same thing. Are there questions on that example? Okay. So now we have on the top right, we've got b minus 13 equals negative 13. So you see that minus 13. To solve for b, we're going to do the opposite. We're going to add 13. So I have my b, and then that's a negative 13 plus 13. And those cancel out, go to 0. And then on the right, we have a negative 13 plus 13. That cancels out as well. So when you have nothing left, we put a 0. So you don't just leave it blank. You don't put a 1. When it cancels out and it gives you an answer of 0, you write 0 there. We didn't write 0 on the left because we already had something else on that side. But if you have nothing left on the side, then you write a 0. So because there was nothing on the right, then we write that 0 there. So our solution set is 0. Bottom left corner, we have negative 23 equals y minus 7. So I want to get that y by itself, which means I need to get rid of that minus 7. So opposite of the sign, it's a minus, so we're going to plus. So we're going to add 7. And so you're always moving whatever is on the same side as the variable, because that's what you want to get rid of. So on the left, because I read this left to right, I have a negative 23 plus 7, which I use my calculator for. And that gives us a negative 16. And then I have a y, and then the minus 7 plus 7, that cancels out, those add to 0, so I don't need to write that. So we get negative 16 is equal to y. So our solution set is negative 16. So I don't really care whether the numbers we have in a problem are negative, positive, or whatever. I just look at what I have. I do the opposite of the sign to get it on the other side. Use your calculator if you need to make sure you do your math right, and then that's it. So you don't need to do any overthinking and say, well, this looks different. What do I do? Just the things you want to remember is you want that variable by itself. And whatever is on the same side of the variable, you do the opposite to get rid of it. And make sure you do that to both sides. And then you just kind of do the math from there. So it doesn't matter that your variables are in different orders or it's on the left versus the right. It doesn't matter that they're different letters. The process is the same. And when you're learning algebra, it's all the process that you need to pay attention to, because there are an infinite many problems that we can give you, and they can all look very different. You're not going to see the exact same problem that you did on the homework on the quiz. There may be different numbers, there'll be different variables, maybe they're flip-flopped in different orders, but the steps are the same. And that's the important part when you're learning math, is to pay attention to the steps, be able to recognize it is in this particular form. These are the steps that I do to solve. And then you follow that. So that way you're not thrown off by different letters or different order or any of that. You really want to pay attention to the process. Now the last one on the right here, I have n minus 6 equals 10. So I want to get n by itself. So it's a minus, so I'm going to add. So I'm going to do a plus 6. And this gives us n equals 26. 10 plus 16 is 26. The negative 6 plus 6, those cancel. So our solution set is 26. Are there any questions? Okay, well, I've got 2 more that are to cover. And then from here, you can go into like my other videos on multiplying and dividing. And then, we start to then combine and do multiple step problems doing both of these things. You kind of add on steps by steps when you're solving. But I wanted to do 2 with fractions just because I know people get nervous around fractions. And so I thought, okay, let's do a couple of fractions. So you'll be just told to solve. You won't be given like what form the equation is in. So you'll just see the direction solve, and then you need to know, okay, solve, let me see what I have. I have linear equations because there's no variables or no exponents on the variables. So that means I'm just going to be adding or subtracting on both sides, or multiplying or dividing on both sides. And you have to kind of look at your form to see what you have and think, do the opposite. So when you have something with fractions, like we have negative 7 equals p plus 2/3. So I want to get the p by itself. I have a plus 2/3, so I'm going to subtract 2/3. Whenever you're adding or subtracting with fractions, you need a common denominator. So that -7 doesn't have a common denominator. So we actually have to do a step first in order to get that common denominator. So when you're thinking through a problem like this and you see something with fractions, that you think ahead, well, what am I going to have to do? Okay, I'm going to have to subtract. Okay, I'm subtracting a fraction, so that means common denominator. So you have to kind of think a little bit ahead and look at what you're going to do, and then that kind of decides your next step. So we have to write that -7, so it has a common denominator with the 2/3. So I need to multiply the -7 by 3, which would give me a -21, and then you write it over 3. So that's going to be a -21 over 3 equals P plus 2/3. So to get a whole number, to have a common denominator with a fraction, figure out the denominator, multiply the whole number by that, and then write it over your denominator. So now that I have those with a common denominator, now I can subtract 2/3 from both sides. So you may find it helpful to do it in a different color. Some people find that very helpful. So I'll just do that in a different color like this. So I'm subtracting the 2/3 because I want to get that P by itself. And so now I've got -21/3 minus 2/3. So when you're subtracting with your fractions there, they've got a common denominator. So we're just looking at the numerator. -21 minus 2 is a -23. So we get -23 over 3 equals P. And then the 2/3 minus 2/3 is 0. And then you look at your fraction and you say, can I reduce this? So -23 over 3 cannot be reduced. We do not make them mixed numbers. So don't make it a mixed number. You'll actually get marked wrong because that is not something that we do when we're doing algebra. So we leave it as an improper fraction. So your solution set would be, and we usually put the negative in the middle, 23 over 3 as your answer there. Are there questions? Okay. Last one. To the right here, we've got 7/3 equals x minus 2/3. So again, we've got fractions. I have a minus 2/3, so I have to add 2/3. Luckily, we've already got the 7/3 already has a common denominator, so we don't need to do anything there. We can just do our adding. So I'm going to add 2/3 to both sides. So 7/3 plus 2/3, 7 plus 2 is 9. So we get 9/3 equals x. And then our 2/3 part cancels, negative and a positive, they will cancel out. Now we want to try to reduce. So 9 over 3 does reduce. That is actually, we can divide that out. You can divide both sides, or the top and the bottom, by 3. And we end up with an answer of 3. So we get 3 is equal to x. So our solution set is 3. If you put into Connect Math a 9 over 3, it would be marked wrong because it's not simplified. If you put a 3 over 1, it would be marked wrong because that's still not simplified, because you can make it a whole number. So even if you reduced the 9 over 3 to get 3 over 1, you have to make it a whole number if it's over 1. Otherwise, it's not considered simplified. So you would be putting in just 3 here. You wouldn't do like a 3 over 1. Are there any questions? Okay, well, that is adding and subtracting the addition and subtraction properties of equality in a nutshell. The next step would be to be learning the multiplication and division properties. And then next week, we'll actually start putting them together. So you'll be doing multiple, you'll be actually, the order that you do first is you add and subtract, and then you do your multiplication and division after that. When we're solving, we actually do the opposite of the order of operations. So, because you're working backwards, so to speak. So that's all I had. I thank you guys for joining. This was a relatively quick one, which usually happens. The first week is usually a little bit longer. People have questions and stuff, but as we get later down into the class, the math will start getting more complicated. The lives will start getting a bit longer because there'll be more steps involved, but they're usually pretty quick in the beginning.